Welcome to the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. Hi everyone, this is Joris Peels, and this is the Prosthetics and Orthotics podcast with Brent Wright. Hi Brent, how you doing?
Hey Joris, doing well, man. I'm excited because I'm coming off this AOPA conference, which has been really neat.
Yeah, how was it? Did you enjoy it?
It was really good, man. Tons of people. They had like 40 new exhibitors at this conference. It was insane. So 170 booths, they said, and 1,500 plus people. And so energy was super high. Tons of 3D printing stuff. So I'm really excited about that.
Okay, that's super good. Do you have an idea? Is it growing much, the 3D printing component?
Man, last time, well, and it was COVID stuff, that you might have seen a handful of booths have some stuff, but I would say like probably 50% of booths had something that was 3D printed in their booths.
Nice.
It's pretty wild. Yeah.
That's good. Dude. And how much was this like 5 years ago? It was like nothing, right?
Not a lot. You had some FDM players that were, trying to go, but yeah, I mean, literally less than one hand of people.
Okay. Wow. Okay. So who do we have on the show today, Brent?
Oh man, this one's going to be a good one. We've got John Naft, and I tell you what, he's got his irons in a ton of files, and so what's really neat about what he does though is he is a big time collaborator. He believes in collaboration. So he not only practices at his clinic, he also is a big part of scanning with Comb Scan, and then he does some really neat kind of myoelectric orthoses that is still kind of the wild west as far as nobody's doing it. So he's kind of paving that way as well. So I'm excited to have him on, and then also just hear his journey, because I don't know that I've dove really deep into that. So thanks for being on the show, John.
Oh, thanks for having me, guys. I'm excited to be here, and I've heard a lot about the podcast, so it's a real honor to be on it, especially coming out of AOPA, where, as you said, we saw so many digital things, and with you as a speaker and moderator at the sessions, people are really talking about the podcast. So, thanks for having me.
Okay, perfect. So, Jonathan, tell us a little bit, like, how did you start your OMP journey? How did you first get into this industry, this craft? How did you start?
Yeah, it's a great question. In fact, I just gave a talk recently to a bunch of high school students about the field of O&P. And also I do some mentoring for college students going in engineering. And I think in most cases when we all go to school or we all think about what we're going to do with our careers, it's not necessarily something that you go out and look for and find. It's something more that finds you. So, for example, with me, it found me through a lot of the classes and internships and work that I did in my earliest days in college. I went to school to study engineering. Engineering was really a straightforward route for me. I was much better at building things, designing things, math and science than I was at other subjects such as English, sociology, history. I liked to build things more than I like to do just about anything else. So my early coursework exposed me in electrical engineering to biomedical engineering, which led me to how engineering can affect the body. Then through some projects in school, I started learning about things such as knee implants, pacemakers, ultrasounds. And then one day I saw some information about artificial limb technology, and this was in the 80s, so it was really exciting to see this evolution. So that sort of directed me in learning more and more about it. And the more I learned about it, the more I really wanted to do more with it. And fast forward to today, after electrical engineering, biomedical engineering, and then becoming certified in prosthetics and orthotics, I'm really about 50-50 between product development and seeing patients in O&P practice.
Does the electrical engineering really give you an edge? Is that different? Because that's the first I've heard of it in the podcast, at least, that most of the people are mechanical or more artisan type backgrounds, but then electrical is kind of new. It seems like it could be a real advantage.
I did find it so in the early stages of my career. So by combining electrical engineering and then doing biomedical engineering, I and practicing O&P, I had some experience that would help different manufacturers and, as Brent mentioned, collaborations. Uh, Back in the early days of O&P, as manufacturing companies were growing, they often employed engineers who were fantastic at designing control systems or designing batteries, designing software, but they didn't necessarily have under their belt the experience of actually fitting a device on a patient. So being able to combine my engineering skill set with my practitioner's skill set, I think really helped me understand what the market needed. Now, as the field has really grown and more engineers have come into the field, you're starting to see more and more of that combination. So I found it really, really helpful.
Yeah. What I think is so interesting about every time we talk about these people, it's like they like to make things generally. It's kind of a maker type mentality. But what I also notice is that there's like a strong entrepreneurship here. Normally, if you're an engineer, you would just go work for other people, maybe a large firm, and entrepreneurship is something you'd only encounter maybe later in life or something like that, or if you join a startup out of college or something. But I think this combination between being a maker and being a kind of like entrepreneur is really quite strong in this community.
Yeah, I'm laughing because one of the advantages of being an engineer is you want things to be better. Uh, Whenever you finish a design, you always look at it and think, well, gee, this could have been this could be better. So I'm going to do this next time, or I'm going to iterate on it one more time and do this. And to a certain extent, we never get finished. So when you combine that with the field of prosthetics and orthotics, you get a patient that comes into your office and they want to bring food to their mouth. They want to be able to hold a fork with their affected arm. They want to be able to walk and walk more smoothly, walk further, run faster with that prosthetic leg. So it just really plays into that engineering mindset for me, which then translates to, well, it just needs to be better and better. And when you put those together, it forces innovation and entrepreneurship, because sometimes I look at things that are missing or holes in the product set, and it's fun to develop them yourself, partner with manufacturers, and put a team together. So I think that's really how the entrepreneurship falls in with me.
Okay. And when did you get started with on like your own thing, when your own business?
Yeah, I've been doing O&P now for 32 years. And when I set out to start practicing after I finished my education at Northwestern, got certified with ABC, I needed a few years, about 5 really, to hone my clinical skills and understand the patients. And my goal was always to really spend at least half my time doing the product development work. So I would say in about my 5th year, I got started. Uh, what I like to say are fulfilling unmet needs in the product development space. In other words, um, I don't have as much passion to develop another prosthetic foot when there are so many prosthetic feet on the market. I have more interest in developing something like a myoelectric arm prosthesis, because there aren't any available that patients really could benefit from, or scanning on your iPhone when there aren't as few lesser expensive, easy accessible alternatives. So I call those first movers in entrepreneurship.
Okay, okay. And so okay, uniquely, you've done a bunch of scanning stuff, right? So what kind of scanning stuff have you done?
Yeah, I started early in my career and with tracer CADs, software and hardware, and then became a beta test. So I used their initial white light scanner, which in our office we nicknamed the Starship Enterprise, for anybody who remembers it, because it really looked like the Starship Enterprise. And I'm not a Trekkie, but I do like I do like the show. But then it was really fun. We started beta testing for Willowwood when they took over Tracer and merged it into Omega. Became a test site for um, their T-ring, which if anybody's used it, it looks like it's about the size of a hula hoop, and it has 5 cameras around the outside, and we use that for scanning, which I thought was a fantastic product, and I still do. I think it's great. Um, Even though it's clearly outdated now, but you can simply hold that around your patient, click one button, and in seconds it's got a full capture. And some people don't know, but you can jump through the center of that T ring and travel through time, which was the genesis of the movie Stargate. For anybody who's ever seen that, not sure if you guys have seen it, but a little sense of humor. That was the movie where I can't remember what was the lead actor's name.
I,
Uh,
I love that the jump through time because man, I actually I was at a clinic a little bit ago and the patient or the clinician had retired and he had one of those old T rings sitting in the corner and I remember that kind of the one button push that was really neat, but it is kind of it, the history of O&P kind of all in one and what a great start.
yeah, it was really fun for me. Oh, and by the way, it was Kurt Russell and James Spader.
There you go.
It just came to me a few seconds later. But then after I started using the T ring, we started buying some more expensive scanners, and then also wanted to try the structure scanner. And I really think they're all good products. It just depends on what your needs are as a practitioner, the resolution that you need, the amount of money that you are able to spend on these. Um, and that's kind of how I evolved and eventually saw the need to design something that could run on your cell phone.
But I think, but like, you're being very positive here, but 3D scanning totally sucks. I've not been as frustrated with anything in my life as 3D scanning. It's like it's just so hard. And you have to clean up the file. And you have to get things right. Go over the geometry. It's so difficult.
Yeah, I can understand that too, and I think a lot of it depends on what you're scanning, how much time you have, and what you want to scan. So, for example, with me the other day, I was scanning a pediatric case, and I was using my iPhone, and I really was moving a lot because I was using my right hand to hold the scanner, and my left hand I was actually holding a small tablet, so I was distracting the child from moving. But then I accidentally, of course, passed my left hand in front of my right hand, so it came across in the scan, which then, of course, caused me to lose tracking for a second. I had to redo the scan. But I think when you compare the frustrations of scanning to the frustrations of taking a cast, that same child would have required me to be on literally my hands and knees on the floor with a 2-stage cast and likely literally producing sweat on my brow because of the amount of physical effort required to take such a cast, which I know a lot of my colleagues would agree. So sometimes scanning can be a really nice alternative. Plus I'm 57 years old now, and I'm not as limber as I used to be, getting up and down off the floor. So it's kind of nice to sit on a rolling stool and scan.
Okay, okay. And so, what did you do with the iPhone or the kind of like the phone based scanner? What did you actually develop?
Yeah, that was really out of need. So I'm a consultant in both some engineering tasks, some clinical tasks, research tasks for a company called Myomo, which is a really fantastic company based in Boston. They had a need, or they saw a need to help people with arm paralysis, usually caused by things like stroke or brachial plexus injury or other neurodiagnosis. And as the company grew, and I was working in managing their central fab operation, we're getting casts in from all over the country. Now, those are hard casts to do because you're often dealing with a spastic arm. And nowadays in O&P, we always do a lot more with less. So you're often by yourself in a patient room, and taking a mold from someone's shoulder all the way to their fingertips and maintaining that arm in the right anatomical position, is hard to do. So we started investigating, well, can we take scans of the arm? And at the same time, in my work in my clinical practice at Geauga Rehab Engineering, we have multiple practitioners, 2 locations, and we wanted to make sure that everyone in the practice has their own scanner. What was happening to us a lot is, I'd come in to start my day and I got to pack up to maybe head over to the rehab center. And I say, hey, who's got the scanner? Who's got that structure iPad? And someone would say, oh, that's in my car. Hold on, let me go out and get it. Or, I thought I left it in the lobby. And next thing you know, we can't find the scanner. I'm looking at my watch. So we wanted everyone to have a scanner. So, the scanners in the range of $5,000 to $6,000 we thought were a good fit for us. But outfitting everyone with that is a little bit of a financial challenge, of course. And we're a small clinical group, so we don't necessarily have hundreds of thousands of dollars in our budget to outfit everyone with a scanner. So we decided, okay, let's go ahead and use Structure, and let's get a Structure scanner for everyone. And I think Structure is a terrific product, but for us in particular, with some of the things we were doing, we needed a little bit different fit. So, for example, we like to scan for AFOs. We like to scan arms for myopros so that we can get a full set of measurements from the shoulders to the fingertips. But with a structure sensor, getting behind the calf when a patient's sitting in a chair was a little bit harder to do. And if you're trying to get measurements from a scan from a full arm, you'd have to have the structure scanner pretty high above the arm, which for some of our shorter clinicians, they had to stand on a stool to do that, or put the scanner practically all the way on the floor. And in a meeting, we decided, well, gee, we've really got to find something that we all can keep as our own. Number 2, we can scan from close proximity. Number 3, we needed a scanner that we never lost sight of the image on the screen. So, for example, with some scanners, as you go around the limb, you may lose sight of it. Or if you're corded and connected to your laptop, you have to kind of wrestle with the cords and try to position your head to always see the computer screen. Um, and last but not least, we really wanted ease of use. We didn't want to have to struggle with a scan box or other learning curves, like you mentioned, that could cause frustration. So we were brainstorming one day and we were talking about, well, gee, our cell phones can recognize our face. Why can't we use that same technology to recognize other parts of the body? And then once we started digging around on the internet, we did see some of the other scanners that do photogrammy and even LiDAR, but none of them were really built by O&P people for O&P specific needs. So that's really the story how we got started. At that point, we decided, well, gee, I think we would be able to make this happen on a cell phone. And instead of reinventing the wheel, I was really fortunate to meet a couple of innovators in Columbus, Ohio, at a company called Knockout Technology. So they were way ahead of us and way ahead of everybody else in terms of making this happen on an iPhone. And they're also just fantastic people to work with. So we were able to license a lot of their algorithms to get us ahead of the curve and get us to work quickly. And next thing you know, we got the whole package figured out. We're beta testing. We're using it for about a year in-house and getting some other partners to use it and give us feedback. And that was the launch of Comb.
And I love that story. I mean, it's two things resonate with me. One is, hey, trying to get around the back of the leg is tough with any scanner. Doesn't matter the price of it, the structure, and what have you. And then two, really, you've now just outfitted everybody. And 3 is that you didn't reinvent the wheel, right? You partnered with some people that were worth partnering with, and that's so neat. I do want you to share a little bit about kind of the evolution too of your AFO fixture. I don't know if you guys have named it yet, but I'd love for you to share that and how that really kind of helps not only get a good scan, but position the patient.
Thanks for asking that. It's a fun story, and we are still working on a better name. And we're at the comb scanning fixture today, and we think we're going to launch a contest on LinkedIn to come up with the name, and maybe the top name suggestion will be awarded a complimentary fixture.
Yeah, but then you get Scanny McScanface if you ask the internet about stuff. You know that, right?
It does make for a good read, though, and at the end of the day, nothing like a big chunk of humor when reading a lot of the posts. Um, but you're right; we are going to get some real hilarious ones. Um, back to your question. I have a passion for solutions and what I again call unmet needs. So when you look at the field of O&P, if we start at the different body parts, I think that there is a lot happening already with people scanning for TLSOs. People are scanning for cranial. People are scanning a lot in pedorthics, things like arch supports and other things that are on just the ankle. But when you look at the volume items in O&P, one of the highest utilization items are custom AFOs. The number of custom AFOs produced at O&P practices around the country is probably the highest volume device. I think spinal is a high volume, but way more AFOs happening. Certainly, way more AFOs than prosthetics. Fortunately, way more AFOs, I guess, than children or infants getting cranial remolding. So here's the highest volume item in O&P, but it actually has the least amount of scanning work. And I was seeing so few solutions in 3D printed AFOs compared to prosthetics. And today, even if you troll LinkedIn and Facebook and you see what people are posting, the majority of cases are always prosthetics. We're starting to see some spinal, starting to see some others, but I was almost never seeing AFOs. So we set out to give that a try, especially because the volume in our office is high. We wanted to come up with some creative solutions, and our drive to do this was kind of both clinical and also something that the patients really wanted to be a part of. Um, I don't know. I would cringe if I had to do another transfer pattern with the butterflies on it on white copoly. Um, it's just it's been there, done that, and it's just it, in today's age of devices, fashion is really critical. And you think about the growth of people putting tattoos on their body as a means of expressing their inner character and personality on their body. When you wear an AFO, you don't want to be looked at as an orthopedic appliance. You want to be seen a little bit more of function first and fashion, as well. So that's what really, drew us to that unmet need on the AFO side. So when we started doing more with scanning, it was really hard to get behind the heel, get behind the calf. So we needed a fixture to hold the leg. There are some really good fixtures out there. TechMed has a really nice plate that's clear. Tuan sells some nice plates as well. But then in my travels across the country and meeting with orthotists, orthotists are conservative, in my opinion, which is a good thing. But most important to them was, well, gee, you got to capture that limb in neutral. And how are you going to do that if you're scanning? So sure, you could put your foot on a clear piece of of plastic, but it doesn't necessarily adjust for inversion, eversion, toe in, toe out, dorsi, and plantar. You have to get all of those adjustments. So in short, that's why we built this triplanar fixture so that we can easily scan behind the leg, and we can easily get that foot aligned to where we want to scan. So then it lessens the entry point in the field. Um, if you take a scan, but you don't have the software or understand how to correct that scan to neutral in all three planes, I think you're less likely to take a scan. But if you can actually get that scan in neutral right where you want it, just like when you're casting, then I think the barrier is a little bit lower. One other quick thought just popped in my head on this. Sorry for talking a little too long on the question. I was at the podium and I got challenged by a member in the audience asking me about the accuracy of correcting a cast on the computer for an AFO. So I showed one in my presentation where using the fixture you can scan a neutral, but if you don't have the fixture, you can still scan and correct your cast or correct your scan. So a member of the audience challenged me that says, hey, well, I see that on your computer screen, you corrected inversion and you corrected your plantar flexion error. But doesn't that lose accuracy? So I stated with confidence in that presentation that what's the alternative? Everybody takes a cast and holds it up occasionally and says, a little bit too plantar flexed. So what do? You take it in the back, you put it on a bandsaw and you cut it and you move it. Personally, I feel more confident doing that on my computer. So all those things came together and we produced the scanning fixture, which I'm really happy to see a lot of interest in. And I hope that really helps move the profession forward to do more AFOs.
And I'd like to go into the weeds a little bit more. I know it seems, Joris, don't fall asleep on us, but this is, we had a little bit of the conversation at AOPA, but I think this is so important, and you touched on it. But I feel like scanning does return some of the clinician inputs back to the clinician. So what I mean by that is, and I don't know whether you agree or disagree, but you have to do a great game plan to get your patient ready to scan. It's not just putting their foot on and scanning. It's what is their range of motion, plantar flexion, dorsiflexion, inversion, eversion. Where can you get them corrected? Can they tolerate it corrected? And with those notes, even if your scan is a little bit off, you have all the end ranges and you can easily do the correction on the computer. So to me, that's fascinating. And it also puts a lot of power into the clinician's hands to do the right type of evaluation.
I'll tell you a funny story on that exact topic. I have the pleasure of having my first resident. So, Kaylee, if you're out there and listening to this podcast, congrats on being such a great student and learner. So, Kaylee and I go into a room together, and we have a 74-year-old female that we're evaluating, and her chief complaint is knee pain. She has Charcot-Marie tooth, and upon presentation, she has a extremely valgus knee. So her two knees are, her affected knee is bent, let's just say sideways, to keep it in layman's terms, towards her other leg by about 35 degrees. So during my evaluation, I put my hands on her leg, and she has a flexible deformity. So meaning I can put my hands on her leg and I can use my hands and bring her right back to practically straight again. Not all the way, maybe like 5 degrees from fully straight. And I asked her if that feels comfortable. And she says, actually, it does. My knee seems to hurt less when it's not bent the wrong direction. So I said to Kaylee, our resident, I said, I want you to take measurements and evaluation and do everything by hand and then hand cast her, because as a resident, she really needs to hone in on those skills. But then when you're done casting, I'm going to go ahead and do the same thing, but I'm going to do it digital with a scan. So what I did was put my hands on her. I used a goniometer and a laser line so that I can identify the degree of bend that I could correct using my hands. So, and then I scanned her. Now, when I scanned her, her foot was in a good position because it was on Combs' scanning fixture, but her knee in the scan was way, knock-kneed, valgus. And, if a regular conservative orthotist who's non-digital would look at my scan, they'd probably cringe and say, well, that's not even close to the right position. So then Kaylee, my resident, takes an actual 2-stage cast where once the lower section dried, she wrapped the patient in fiberglass up to her groin, and then held it there while it dried. So then she takes the cast off the patient, and we did a comparison after the patient left. So we had the hand cast. Now, it had deformities from her hands holding the patient in this corrected position, and the cast wasn't exactly where it needed to be. So once again, it gets cut and wedged and corrected in the lab to a point where you think it's okay. And then you have to use plaster to go ahead and fix the hand indentations in the thigh. And you're doing that purely as, I would say, a craft or an art. I would say that's something that is both inherent in the skill set of the artist part of our body as orthotists. And it's also something that experience gives you. So that took her, let's just say, hours. I didn't actually measure it, but it took hours to do. Whereas on my computer, I had no deformation in the thigh or in the lower leg from holding it. I had a very, very smooth surface. And then what I did was I used my skills as the orthotist to know, well, gee, that leg's not in the right position. But with my hands, I corrected it to -5. So then I did the same -5 correction on the computer. And I just felt it was incredibly accurate. We've went ahead and we fit the KFO using the digital process. It was fabricated, that one, by Tilgy's Technologies up in Minneapolis. And boy, the patient just loved it. Super lightweight, corrected her valgus. She has a decrease in pain, and it was all done through digital.
Wow, I think that kind of stuff is really. And do you? That's kind of interesting. But you wouldn't have done. Would you? Yeah, but would you have known this if you? Or would you have known how well it worked if you didn't have her do the cast? Or is that just like the really exciting thing you found out just because you had a resident?
I think taking a look at the comparisons is really helping me. I really can't say that just 100% of the time doing your work digital with a scan and a computer is better. I think it has advantages. In the end, someone who's casting with plaster, modifying with a rasp, thermoforming plastic can certainly produce a great device. And no doubt, way better than anything I can even do digital, depending on who's doing it. But I think for certain circumstances, it's really, really an advantage. And doing some of these A/B comparisons is going to get us there. And in the end, the only thing that really matters is your patient. I have this motto when it comes to developing products that the market decides. We as developers and engineers and clinicians, we don't decide. And if I'm fitting patients in digitally produced devices through scans, through computer modification, through 3D printing, and my patients are happy, I mean, we track our outcomes. So we know when things are going well and not going well. Especially, if a patient's not doing well, they're going to call you. Or when we check in with them, we find out, well, they're not wearing the device. We bring them in. And for us, we do see a really high success with working in digital. And I think as that starts to get compared, as there's more, research that gets done, and we track outcomes, really long term, I do predict and think that we're going to see a much higher consistency when people are working in a digital workflow versus, an old school plaster workflow.
But then, what I automatically think about, and we've talked about this a couple of times before, is that digital may lead to many more contract manufacturers or kind of more of a, standard solutions with a lot less like people actually making their own devices. Let's say it's going to just lead to more outsourcing and stuff like that. Do you agree with that, or you don't think that's necessarily true?
Well, I'm the perfect example of that. So most of my career, we've had a lot of technicians in our own lab. And then as time went by, occasionally, like we had a technician retire, and we were maybe, let's say, sending out outsourcing about 10% of our work. If somebody retires as a technician in O&P, the thing that we all know is how hard it is to train a new O&P technician and how long it takes for an O&P technician to really become proficient. That's again, a mixture of hand skills, an art, and workmanship, and that's just not something somebody learns in 2 weeks. But you can learn the digital tools pretty quickly with some really more of the straightforward software packages. And for me, as time went on, it was harder and harder to get technicians and find and recruit technicians and train them as it was to grow into the digital workspace. Um, so we in our place have far less technicians and more digital, and we're outsourcing. We tend to do a lot of the work ourselves on the computer, and then we go ahead and we send that file out to like on the orthotic side, we could send it to Kinetic down in Tampa, who will fabricate from our scans, or we'll send it, like I said, to Tilgy's up in Minnesota, and they'll fabricate from our scans. And just frankly, those guys can make a better device than we can in our shop. They're, even if they're doing a hybrid fabrication, such as like a pre-preg carbon or a lamination, they can just do that better. And then when it comes to if we want to 3D print sockets or brace shells, we don't have a HP Multijet Fusion printer in our office. And with our volume, what it is, I don't see any other solution than outsourcing. Plus, the technology is changing so fast. I think we're just going to continue to outsource. And I think you're going to see more and more of these central fabs. I was talking to Joe Fairley, who started Ascent Fabrication. And, he's all digital. And I think you're going to see more and more of that start to grow because people don't necessarily have all the hardware in their office.
I think, yeah, I think, but then the logical thing there is like, why would I do this in the United States? Why don't I do it? Like, we have this already in, like, for example, in Invisalign, which is like one of the biggest 3D printing applications, where we're making the positives for the thermoforming inserts for Invisalign, the braces, right? And orthodontic devices, right? And there we see a lot of the file handling happening in places like Costa Rica and Puerto Rico and stuff like that, and printing as well. And is that going to happen, do you think, or is this something that you should keep in the United States?
It is a big discussion that happens. In fact, I was at a really interesting lecture. I think, Brent, you were the moderator, and someone from the audience came up to the microphone and felt that there was a recommendation that somebody made could cause an encroachment by unskilled people into the field of O&P. In other words, well, gee, if this becomes so easy and accurate, then do we really need a certified prosthetist and orthotist to do it? And that is not a concern of mine at this time. The reason being, as one who fits devices, every day, the real skill, I think, happens in the room when you fit the device. I think whether a device is 3D printed or conventionally fabricated, when you put it on the body, there's a certain level of fine adjustment that needs to be done by somebody who really has experience and is well trained. The ABC certified orthotist goes through a rigorous education platform, and it does translate into the room. So taking that device, which has been digital workflow design, still requires that extra percentage of skill to make it just perfect. And that little bit of difference is often what it takes to get somebody to wear their device all day long, every day, instead of, well, gee, I just got home from work and man, I'm just so fatigued and this thing's hurting my limb and I got to sit down. I don't think that's going to go away anytime soon.
that would fundamentally change. Like you'd have like a fitter, fitter and interviewer. Really, basically, that would be the key skills. How to make the person comfortable, how to talk to them about, how to elicit, like and fitting. And then the fabrication would be, maybe we do it in India or something like that. Is that something? Would that be a good or bad thing? I have no idea to see if that would just make it super cheap for everyone to do this, or if all of a sudden we get quality out the window and nothing would happen.
Yeah, I'm still bent on the quality piece, and I really believe the profession of O&P, especially those that are really certified orthotists and prosthetists, are too bent on the quality. If if the quality is better through outsourcing, um, then sure, that'll happen. And I guess here I can give you a real life example, and I think Brent has seen a little bit of this as well. In my quest to find the best possible AFOs for my patient, I have found companies that are outside the U.S. like a Spenties, for example, or an Ability Made in Australia, where back in my back in my non-digital days, I'm really not going to take a hand cast, put it in a box, and ship it to Australia or ship it to Belgium for an AFO. But now I can email them a file, which gets there in seconds, which doesn't get lost in shipping, doesn't get damaged in shipping, and I can really source out a true expert, something with a device that's truly novel, lightweight, very nice looking, and they can design it for me and then email me the file back, and I can then have it printed locally right here in the U.S. So I do think that's going to grow.
Yeah,
Um,
I love Spentis, by the way. I love that, and I love that. I mean, to me, it's just absurd that all you guys are doing the file cleanup to a certain extent, and a lot of this, like, let's make it positive and let's make, you know what I mean? And I just that should be automated. That needs to be automated.
oh yeah, 100%. So I'm in the middle of an experiment now where I'm teaching, some of our technicians to do their instead of doing plaster work, they're doing it on the computer, and they're learning that. And at the same time, me as a practitioner, some of my colleagues that are practitioners, we really can't spend the time in front of the computer doing all of our modifications and cleanup. So for me, it's a wonderful workflow where I just take a quick scan and then send it out to an expert, let them clean it up, let them do the design. These guys have also spent a lot of time testing their designs, whereas a lot of the original O&P designs have never been halt tested or any other real engineering tests. So I do think we're going to see more and more of that collaboration and outsourcing.
I think it's inevitable. I think especially like we always waited for scanning technology to improve. That's been, I think, the hold back. But I think if we look at a lot of other markets, it's maybe irretrievable, or what you could see is like more complete devices maybe emerging, and then more customization being done, kind of more of a kind of IKEA kind of change from based on more readily made components. You'd order like an interface and certain other things, and just put it together in your house. And some stuff will come from whatever China, and some other stuff will just come from New York or whatever. But I'm also interested just in the business of OMP, because like you make the scanning business, you make a product catering to OMP. I mean, but that is it's a relatively small market. It's not like 100 million people or something. It's a really quite a small market. And what's it like doing business for developing a software product for just a relatively small market? Because you could, yeah. Well, what's that like?
uh, so we don't have a webcam on, but you could see the extra gray hairs that have come in the last 2 years. I have pitched several different companies that are not necessarily in the O&P space to collaborate to work with me to produce products for the O&P space, and they'll come back with it's too small, therefore it's too financially risky. It is a very very small market. Um, so risks have to be done, and taken very, very calculated. So you estimate the size of the market, how many sales you think you can make, and then you have to come up with ways, to have something that is our reoccurring revenue to sustain the product's growth. So I would say that's probably one of the biggest risks and challenges is the small side of the market, and there are many bigger players who just they don't want to put the focus on O&P because it's too small, it's too risky. Um, and I think for me trying to gain market share in orthotics and prosthetics, it's really about I think two things: putting out the best product that we refer to as bulletproof, so something that is going to really, really work easily, really work consistently and well, so that we can have as much market share as possible. But then the second piece is really that collaboration. In scanning, we can't sell a scanner to anyone unless they know what to do after they take a scan. When we first came on the market and we're showing people, hey, you can scan now with an iPhone, and we've done a lot of testing, and we believe that the number of scans a person has to take is only between 5 and 7 before they really are pretty proficient using the scanner. But yet they're not buying the scanner for 6, 7 months because they don't have everything after the scan figured out. So that's when we quickly realized there's a lot of folks out there that do things after the scan. So partnering with those companies and cross promoting and working together, I think accomplishes two really important things. One, it helps us all in business, as you mentioned, because the field's so small, we have to gain as much market share as possible. But then two, it gets people doing more digital. It gets them off the fence and gets them working in it, which then results in more sales. So hope that answers your question. But all in all, developing products in O&P is really risky because it's also a reimbursement-driven profession. So there's no reimbursement for scanning. So it really has to pay for itself in efficiency.
Yeah, but it always just seems as that's kind of the mantra. It's like, okay, reimbursement is difficult. The market is small. Everything is custom. So we kind of get stuck in this loop where everything's kind of expensive, which makes it small, which makes it, you know what I mean?
Oh yeah, yeah. Um, it is, and for us, sorry for the delay there. Um, that's other reasons why companies like Comb have to grow with additional products. If the field itself is so small and there's really a finite number of scanners that we're going to sell, then we're going to come up with the scanning fixture, which hopefully will really be the most sought after scanning fixture in the industry to do KAFOs, knee braces, AFOs. That will bring us the revenue to help sustain the company, as well as then it'll keep selling more scanners. Um, we all of us at Comb had a mini celebration at AOPA because that was the official launch of the scanning fixture as our second product. And then as soon as we all got done shaking each other's hands, I immediately started throwing ideas on the wall for what's going to be next. So, hey guys, don't rest up too much. We got the next best thing to develop at Comb. So we're going to have to keep pushing with new products because it's a small industry.
Yeah, definitely. And how do you split your time between your different endeavors? Because I always thought this would be super difficult to either like, you'll have one, you'll spend a lot of time on it, and then the other one will be kind of a little orphaned. How do you do that?
Well, I'm going to tell everybody the secret. I actually have a twin brother, and we go by one persona and one name.
Excellent, excellent.
Yeah, so there may be two of us, but we're each called John Naft, and and we're identical. So, no, truthfully, it did take me a while to learn time management and prioritization. I'm exceptionally loyal and passionate about the growth of Myomo, and I've got my nose to the grindstone there, working on research, working to assist the engineering team, and other roles there. And I'm also working really hard with Comb in my clinical practice. So, each month, each quarter, and each year, I do have a written plan of what's going to get executed, what's going to get accomplished, and how it's going to be done. And it's really broken down to the week. So I use a really well organized task list, and I'm pretty good now at estimating the amount of work that it takes to get certain tasks done. But in sincerity, the real secret is surrounding myself with colleagues and coworkers where we all truly complement each other and can accomplish tasks in an efficient way. And I really trust my team. They're really good. Um, Clearly, I can't do everything, and they can't do everything. So we'll divide and conquer. And I'm just really, really fortunate to be surrounded by people who are so much more talented than I am, smarter than me, uh, and are just great at executing. So I may be helping to steer and drive the ship, but it's surrounding myself with talented comb, talented GRE, our clinical practice, and at Myomo, it's some of the smartest and most talented people I've ever worked with. So I think really that's the secret, because it can get hard, and the nights get late. I will admit I probably I work 7 days a week, like many of you, and it's mostly because I just love it. Um, it's really what I like doing. Last comment, had my first meeting to talk about retirement with my advisor, and the meeting didn't go very well. The meeting didn't go very well because because his first question was, "Okay, so when do you think you're going to retire?" And that's not even on my radar. He said, "Well, it's important to start planning for it now." I said, "Great, that's why I'm here." He says, "Okay, so when do you think you're really going to start to slow down?" And I just truly enjoy my work to the point where it's hard for me to imagine that right now. So I'm sure with time we'll consolidate a little bit. I'll slow down. Um, and again, I'm blessed with so many great, talented people. They'll start taking over some of the roles that I do. So that's my short story on time management.
But it's crazy important if you think about it. If you're doing so many things, and then a lot of people like that kind of practical stuff that often they don't teach that in school or that kind of thing. But that is kind of why a lot of things go sideways for a lot of people.
Yeah, I think I was a victim of need to learn. So um, once I decided that I really wanted to have, the timing was right to develop comb, even while doing some other things, it just became clear: get the right team together so that those guys can lead.
And also, we didn't talk at all about Myomo actually.
We'll have to get him back on.
Oh man, okay.
Yeah,
Yeah,
that's a whole nother thing, and that's a whole nother just section that is underutilized and under in
yeah.
the whole orthotic field, is this idea of myoelectric orthoses, that so many people are affected by upper extremity deficiencies of some sort, and they can really benefit from what Myomo is doing. But yeah, I really look forward to digging into that. If John will come back on with us sometime.
Yeah, I'll leave you with just a short tee up on the work with the MyoPro. Um, when I was seeing all these AFO patients, especially those with stroke, they come in with hemiparesis. So 82% of the people that I was seeing for an AFO also had arm impairment. And they would say, "John, this is great. Thanks for helping me with my leg. And my leg is supported by this brace so I can walk." But then they'd point to their arm, and there's just such fewer alternatives for the arm. So they were walking out of the office in a sling. They were walking out with an impaired arm that they couldn't use. And fast forward to today, I really think that we've made tremendous progress, in that space, where there is just so many research studies that have been published now on it, and it's just grown to the point where I think when I first started working on the MyoPro, there were maybe 6 or 8 of us, and now there are over 110, I think, employed at Myomo, and each generation keeps getting better and better, and the barriers by the insurance companies are starting to lower, which is just it's just great news for the patients who really need this device. So yeah, I'd love to come back, talk more about that. And it's not just Myomo. I mean, you're seeing growth in companies like Autobach, who now have a computer-controlled leg brace called the C brace, which is just a remarkable piece of equipment that helps people walk better. And you're also seeing all these lower extremity exoskeletons. So people with spinal cord injuries who have otherwise been in a wheelchair are putting on lower extremity exoskeletons, and the things that that's allowing these patients to achieve is incredible. And the next 3 years are just going to be freakishly exciting, especially when we'll next starts to see implanted electrodes and brain control interfaces. So yeah. Anytime you guys want to have me back, hopefully this was valuable for the listeners, and I really thank you for having me.
Thank you. It was a real pleasure. Really enjoyed it very much. And thank you again for being here as well, Brent.
Oh, this was great. This is neat to hear the journey and kind of what's coming next.
Yeah, well, you guys rock, and I so appreciate the way you're promoting digital, and it's just going to keep growing. So thanks for all your hard work.
Well, thank you. And thank you for listening to our podcast. Tell all of your friends. This is the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. And thank you very much for your time. Have a great day.